Here we start dealing with a midpoint formula. First they ask us to write the formula. So just remember that a midpoint, it tells you the format that your answer, your formula should be in your answer. It's a point, so it should have the format of a parenthesis, then a number x, comma, then a number y, comma, then close parentheses. So that should help you remember what you're going to be writing here. You're going to take the two x's of the endpoints, find their average, which means add them together, divide by 2. Then you're going to take the y's of your points, add them together, divide by 2. Remember, midpoint is average. It's the averages of the x's and the y's. So when they ask you in problem number 2 to determine the midpoint between these 2 points, you're first going to deal with the x's. Add them all together and divide by 2. So that's going to be a 1 plus a negative 3. All of that divided by 2. And then you're going to take the y's, these are the values, and you're going to add those together and divide by 2. Go ahead and start putting our formatting here so that we don't forget to use it at the end. When we are simplifying fractions, we need to remember to simplify the numerator first and then divide. So that's going to be a negative 2 divided by 2 and a 10 divided by 2. Remember that the fraction line, in reality, all it means is division, so we have to divide those numbers. You get a negative 1 and a 5. That is your midpoint for this problem. Next, given that the coordinate m for midpoint, is 6, negative 2, remember that when the midpoint is given, we circle it because it reminds us the procedure is different from what we just did here. We're not just doing an average, the midpoint's already given. What we do know is an endpoint. So when the midpoint is given, you go ahead and write it again. And I scratch it out from here so that I don't accidentally use it again. So once we do that, we separate them because we're going to be doing something to either side. And like a butterfly effect, where the symmetry goes to either side, we put an equal sign on either side. And then we're going to write our midpoint format here, which is x's divided by 2, y's divided by 2. Let's figure out what the x's are. We have one endpoint here, and the other endpoint, which is the one they're asking you for here, is the one we don't know. It's an xy that we don't know. So these values are the ones that we're going to be using on the numerator of our fraction. So 3 plus the x that we don't know goes on the x side. And then the y plus the y that we don't know goes on the y side. What we have to do now is solve these two equations. Fortunately, the procedure is always the same in these cases. You're going to multiply both sides by 2. This 2 is used up to cancel out the denominator 2. So don't then use it again to multiply up here. We already used it up here to cancel out the denominator. It's like if you use $1 to buy a bottle of juice, you cannot then go ahead and use that same dollar to buy a bag of chips. It's already been used. So we have 3 plus x is equal to, remember this is now 6 times 2, so it's a 12. Then we solve this, subtract 3 from both sides, and x is equal to 9. Same thing on the other side, times 2 and times 2. This 2 is used up to cancel out that one, so we have 2 times negative 2 is a negative 4. And the numerator is what remains, 4 plus y. When we solve this, we need to subtract this 4 that's here with the y. Now be very careful here, because it's very tempting to say 4 minus 4 is 0, but that's not what it says. It says negative 4 and another negative 4. Together, those make a negative 8. So we have found that the coordinates of our point B are the x that's a 9 and the y that's a -8. Moving on to the next problem. Write the distance formula. Remember that the distance formula is you subtract the x's of your given points and square it. Put a plus in between. You subtract the y's from the given points and you square it, and all of that goes inside this little square root house. What other method can we use to find distance? Remember that we can also use the Pythagorean theorem. So if they give you a coordinate grid, and you have a point given here and another one down here, remember that to find the distance between those 2 points, you can always do this little right triangle shape from one point to the other, measure the side length, and then use to find the distance c squared is equal to a squared plus b squared, where a and b are the other 2 sides of the triangle. So we can always use Pythagorean theorem. In fact, many people find the Pythagorean theorem easier to use than the distance formula. What other direction can be used instead of find the distance between points A and B? Many times we see the word distance replaced by the word length. We must know that it's exactly the same thing that they're asking us. In problem 7, they ask us to find the distance between these 2 points. We're going to be using the distance formula that we have up here. So let's see how we use that. You take the x's, which are the front numbers of each point, and you subtract -4 minus a -2. And you square it. And you put a plus in between, and then you take the y terms, you subtract them, 6 minus a -4, and you square them, and all of that goes inside the square root. Keep in mind that these 2 negatives here together become a positive, as do these 2. 2 negatives together become a positive. So really what it says is a -4 plus 2, so that's just a -2 squared plus 6 plus 4 is a 10 squared. Any number squared means you're going to multiply that number times itself, so -2 times -2 is actually a +4. And 10 times 10 is actually 100. So we have the square root of 104, which if we use our calculators, we produce the decimal 10.2. Sometimes they ask us to give the answer in simplified radical form rather than in decimal. So let's review how to do that. You have the square root of 104. And you can think about, this is a longer method, but it's easier for many people, so let's try that. Start dividing by 2, and 104 divided by 2 is 52, and then you divide the 52 again by 2, and you get a 26, and you can divide that again by 2, and you get a 13. And once you get to the 13, you're stuck. That's a prime number. So among this chain of numbers here that are your factors, you find pairs of the same number. Those pairs go outside of the square root, and any numbers that do not have pairs are put back inside the square root symbol. So a pair of 2's becomes a single 2 on the outside, and on the inside I still have the 2 times 13. So our simplified radical form is 2 times the square root of 26. This value and 10.2 are the same value, just one of them is expressed in decimal form and the other one in simplified radical form. In the next problem, they're asking us what is the perimeter of the figure. Again, a math word here, which we should define so that we know exactly what they're asking us to do. Perimeter means you add all the sides. So no matter what procedure we do to figure out these side lengths, we know that at the end we're going to have to add them to find our final answer. So that we don't forget that at the end of the problem, I recommend you write the words add all sides and then put a line so that no matter what work you do here in the middle, you don't forget that at the end you need to fill in that blank and add all those sides. So, first thing we need to do is figure out the side lengths. Some of them are easy to find. If the side lengths go straight along the lines of the coordinate grid, we can just count the blocks. This one is 1, 2, 3, 4, 5, 6. This length is 1, 2, 3, 4, 5, 6, 7. And it'd be nice if we could just measure this diagonal, like this hypotenuse along the coordinate lines, but this line crosses the white spaces, so we can't really just count the blocks because it's not the same thing. We actually need to figure out the side C using our Pythagorean theorem. C squared is equal to A squared, which is going to be our 7, plus B squared, which is going to be our 6. That means C squared is equal to 49 plus 36. When you add those two numbers together, you get 85. But now, we still need to get rid of this exponent of 2 because we don't want to know what C squared is. We want to know what C is. So to get rid of an exponent of 2, we need to use the square root. That way a squared and a square root cancel each other out. What you do on one side, you have to do on the other. That way, you end up with just the C on the left-hand side. And the square root of 85 is the number 9.2, rounding to the 10th place. So, many times we're tempted to say, oh, okay, this is our final answer, but thankfully we wrote a reminder to ourselves that this is not the final answer. We still need to add all the sides. So we still have that 9.2, which we add the 6 and the 7 to produce our final answer, which in this case is 22.2 units, whatever the units may be. This is really our final answer. Good to know, because if you are doing a problem, for example, in the SOL on the computer, where you need to select your answers, probably this 9.2 will show up as one of the answers, and the 22.2 will show up as the other one. And if you choose to stop here, it's going to look good because the answer shows up in your multiple choice. But the person that really pays attention to the instructions remembers to do this last step and correctly produces the right answer of 22.2. So please watch out for that. Here, given a line segment AB, where the distance between A and B is 6 and the midpoint is the point 3, 2. Is this enough information to find the exact coordinates of A and B? Well, I would not think so, and here's why. If I have my coordinate grid like this, and I find the point 1, 2, 3, 1, 2, so 3 2s right here, that would be my midpoint. I don't have any other information, so I could produce this red line here and make both sides equally long and then say that my points A and B are there. And that line does have a midpoint of M, but someone else might choose this other line. A and B up here and still have the same midpoint. So there's many lines that could have this same midpoint. So as it is, we do not have enough information to find the exact coordinates of point A and B. Here, if Tom is playing golf, he starts at point 4, 3. He then hits the ball and it lands at point 11, 5. So it went from 4, 3 to the next stopping point of 11, 5. After that, he hit the ball again and it lands at the hole at 12, 7. So now it went from 11, 5 to the location 12, 7. So the ball traveled a distance, first distance here, and then a second distance down here. And they're asking us what is the total distance the ball traveled from starting point to end at the hole. So we need to find two distances. The first distance goes from 4, 3 all the way to 11, 5. The second distance goes from the point 11, 5 to the end location of 12, 7. So we need to find both of these distances and then add them together at the end. So let's use our distance formula. For the first point, we're going to take the x's and we are going to subtract them squared. Then we're going to take the y's, plus in between, 3 minus 5 squared, and all of that goes inside a square root. That is equal to the square root of 4 minus 11, that is a negative 7 squared, plus 3 minus 5, that is a negative 2 squared. Now remember that anytime you square a negative number, you're multiplying a negative times a negative, so your answer should always be positive. Negative 7 times negative 7 is a positive 49, plus negative 2 times negative 2 is a positive 4. So that means you have the square root of 53. And we can find the decimal value of that, which is about a 7.3, rounding to the 10th place. Let's do the same thing here with the second distance. The x values first, 11 and 12. I'm going to subtract those. 11 minus 12 squared, plus the y values, the 5 and the 7. 5 minus 7 squared, and all of that goes inside the square root. 11 minus 12, that's just a negative 1 squared, plus 5 minus 7, again we get a negative 2 squared. That is negative 1 times negative 1 is just a positive 1. Negative 2 times negative 2 is a positive 4. So we have the square root of the number 5, which rounding to the 10th place is a 2.2. Remember that they wanted to know the total distance. So we have to take the 7.3 and add it to the 2.2 to produce our total. When we add those numbers together, we have a 9.5, and this is our final answer.